Hello, I'm Mrs. J, and welcome to my math class. Today we're doing chapter 12, which continues on probability and has more than one event. So you have to decide whether it's independent or dependent event. An independent event does not rely on each other. Where a dependent event can change the probability of the other one. It can depend on what the first one does. One way of thinking about it is if you're pulling two cards from a deck of cards. If you pull one card and then replace it and pull the next card, then you still have the same number of cards. Your probability stays the same. It doesn't rely on the first one. Where in the dependent event, if you pull a card and say it's an ace of hearts, well then when you go to pull the second card, if you don't replace this card's no longer in there. So you not only don't have an ace of hearts in the deck, you only have 51 cards. And so it depends on it. So a dependent event depends on what happens in the first event. So we wanted to look at the probability of pulling a heart, replace it, and then pull another heart. From a deck of cards. Well, when you have probabilities, when you find the first one and then the second, you can multiply them together. And so if we do the first one, the probability of pulling a heart, we know there's 13 hearts out of the 52. But then we're putting it back in, so when we go to find the probability of the next heart, it's still the same 52 cards, which makes it 13 out of 52. And then you would just multiply those together. 13 times 13 is 169, and 52 is 2704. Whereas in the other case, if we find the probability of a heart, do not replace, and then probability or another heart. So we want to know if we pull a heart from a deck of cards, we don't replace it, and then pull another one, what's the probability of that? Well, we already know the probability of the heart. It's 13 out of the 52. But if we don't replace that heart, then when we go to pull the next one, there's not 13 hearts, there's only 12, and there's only 51 cards. So this probability depended on what happened here. But you still can multiply those probabilities together. So it does change your probability whether it's independent or dependent events. Let's look at a few more. What if we roll a die and toss a coin? Well, first let's find out how many outcomes there are. To find the number of outcomes, when we roll the die, there's 6 outcomes. When we toss the coin, there's 2. Now this is an independent event because rolling a die has no conflict or problem with tossing the coin. It's not going to change it. They have nothing in common. So this is independent. Well, what you can do then is find the outcomes that are possible for each and multiply them. So there's 12 outcomes. If you don't want to find your probability this way and by multiplying, when it's a small amount, you can list them. So if we list the possibilities, for a coin we'll just use H and T for head and tail. We could have heads in a 1, head in a 2, head in a 3. And then a tail with all of them. And if you count those are 12. So always find out how many you need so that if you are listing them, you've found all of them. And let's look at some probabilities. And what about the probability that it's a head and a 4? Well, there's only one that is a head and a 4. So it's 1 out of the 12. If you did it the way we were doing it earlier, the probability of the head would be 1/2 times the probability of the 4, which is 1/6. Multiply them together, you get your 1/12. But I think having the list is a little easier. Now you need to be careful of the wording because if we had or, that would change our answer because a head or a tail, well, all of these are heads. Sorry, a head or a 4. All of those are heads. And then this one's also a 4. So it's not only the 6, it's this one, 7. 7 out of 12. So you do need to be careful of the wording, whether it's an and or an or. How about tossing 2 coins? What you get on the first coin has no relationship to what you get on the second one, which means it's independent. When we toss the first coin, 2 outcomes. Second coin, 2 outcomes, which means our outcomes should be 4. So think about what the outcomes would be. You'd have 2 heads. The first coin could be a head and then a tail, but the first coin could have been a tail and the second one a head, and then the 2 tails. So the order does matter because you got to think of it as the first coin and the second coin, which means you're more likely to have a head and a tail than both heads or both tails, which makes sense. So the probability that they're both heads is 1 out of the 4. Remember, we can write probabilities as fraction. If you divide those a decimal, we'll multiply that by 100, a percent. If it doesn't specify, I'm fine with any of them. Well, what if we need to toss a coin 10 times? How many outcomes are there? Well, we'd be, instead of just 2, we'd be doing this 10 times. 2 times 2 times 2. So there'd be 10 of them, or 2 to the 10th. Which would be 1,024. So there's a possibility of 1,024 outcomes. I don't think I want to list all those. So what you could do is, if we were finding the probability both heads, or all heads, not just both. So the probability that all 10 of them are heads, well, there's only one way for that to come out. So it's 1 out of the 1,024. So even if you know all of the possibilities or the outcomes, then you can still find the probability. Some of them are harder than others, but another thing you can think of is when there's too many of one, like the probability that they're not all heads, which means 9 heads and a tail, 8 heads and a tail, 7 heads and the rest are tails. You could take the probability 1 minus the opposite. Which would be 1 minus the fraction that we already found, which is 1,023 over 1,024. We're not going to get into much more detail with probability in this section. So that's it for today. That's it for today. Okay. Stop this.